Hello, everyone. Welcome back to Calculus. We are studying the derivatives of trigonometric functions. So far, I suppose you remember there are three formulas, right? Derivative of sine, it turned out to be cosine. Derivative of cosine, it turned out to be negative sine. And also, we do have derivative tangent, which is secant squared. Speaking of tangent, it's worth to mention again you are going to know trigonometric identities very well, and you are going to know those old rules, the rules we learned in previous sections, like the quotient rule and like the product rule, and indeed all the rules we learned before. Okay, certainly in this case, it only involved with the quotient rule here. Derivative tangent is secant squared. And also we answered one classical example. It is about the equation of the tangent line. Okay. How about let's do a little more examples. And I think I have two more, or maybe, yeah, a little more than two. Okay, let's take a quick look at what we have anyway. Okay, so the next example I just took from the textbook directly. It is example 3.4. It is from find the derivative of a function g. G is in the fashion of cosine of x over 4x squared. So clearly this is a quotient, right? This is a quotient. So I'm taking u as cosine x, v as 4x squared. And then I calculate the u prime and the v prime. Help me double check if I'm all right. And also, just to remind myself, and I hope you will do the same when you're writing homework problems, copy down those formulas. Okay, at least copy each formula a few times and just make sure they stay in your mind. And then after a while, if they do stay in your mind, you can skip some works. For now, I suppose mostly we are new to those rules and the formulas. So I repeat the same quotient rule again. I know G prime, it is from this arrangement of the quotient rule, U prime V and minus UV prime, and the V squared, denominator squared. That is 16x to the fourth power. And then what I did for the next part, it is about the simplification. I'm saying for the numerator part, 4 is a common factor, right? So you factor out 4. And also x is a common factor. Factor out 4x to the front as a common factor. Then for the first term, I'm still having negative left. 4x squared, take out the 4x, still there's x left, times sine x. For the second term, take out the 4x, keep in mind. So we only have 2 left, certainly with that cosine x. Okay. Then after factoring out 4x, I suppose you see this 4x, indeed, it is also a common factor to the denominator. So it's canceled. It's canceled. The denominator tends to be 4x cubed. And then 4x canceled, I have those things left. So really, this is a derivative question involving with trigonometric functions. And quotient rule, it's a pretty big thing, right? And then, well, remember we said that we have high order derivatives. It is interesting to visit the topic again, especially for trigonometric functions. And you see a lot of sines and the cosines. I'm not sure if you are confused, or at least I say they might look very interesting. So let's take a quick look about some of those high order derivatives. Y equals sine x, it's a given function. So speaking of derivative, the easiest way to denote the derivative, it is y prime. Also, I say this might be the best way, dy dx, because later on we may have a function r of t and r of s, u of v, those things. dy dx, it simply indicates we are having a derivative and then function y of x. Y is the function of x. So that is cosine x. And then this notation, y double prime, it's the second order derivative. And then indeed, also I want you to know we do have the notation, d dx notation for the second order derivative. It is written as d2y dx2. That's for y double prime. And it is a derivative, right? So derivative cosine tends to be negative sign. And also we have the triple, y triple. That's the third order derivative. Accordingly, using the dy dx notation, it tends to be d3y dx3. And it really doesn't matter. The third order derivative, it is the derivative of the second order. So at this moment, minus stays, sine tends to be cosine. And then for the even higher order derivatives, you could continue using primes, but anyway, I guess it's a little harder to read all those primes. So instead, we just write this as the fourth order derivative, y parentheses with 4 inside. Okay, y simply without a parentheses, it may confuse with y to the fourth power. With parentheses, it simply says that's a derivative, fourth order derivative. Then fifth order derivative, we put a 5 there. 6, that's for the sixth order derivative. Okay. And this time, I guess maybe dy dx notation makes a little more sense. d4y dx for that's sine x. You take a quick look. The interesting thing about the sine x, well, I should have mentioned the sine x itself, it is a periodic function. And somewhat you take the derivative continuously for sine x, okay? In 4 rounds, right? It turns back to itself. It turns back to itself. The fourth order derivative is the function itself. Then I suppose, the fifth order derivative would be the same as the first order. Sixth order derivative would be the same as the second order, and so forth. So forth, okay. So you take a look if those higher order derivatives make sense. And similarly, actually, we do have similar conclusion for y equals cosine x, y equals cosine x. After 4 rounds of calculation, the fourth order derivative turns to be itself for cosine x. So there are a lot of similarities between sine and cosine. And if you have any questions, let me know. Derivative of trigonometric functions should be very simple, I guess. 3 formulas: derivative sine and the cosine and the tangent. And honestly, at least on the test, I will not ask any question about the secant, the cosecant, those things. It's only about the sine and the cosine. It's also worth to mention, if you have to deal with sine and the cosine or secant, the cosecant in class, maybe you want to consider reciprocal identities and the quotient identities. Okay. And speaking of homework problems, I think I do have one more problem on my notes. Let's take a quick look if that's very helpful. This indeed, it is one of the homework problem in the exercise part, number 210. It is the homework problem, okay. It is to find out the second order derivative, d2y dx2 for this function. So this is my work. And if you needed, do take my work as a reference. Okay. So in order to get the second order derivative, you cannot jump there. And we must calculate the first order derivative. So one thing I realized, this function, it is sum of 2 terms. There's no issue for the first term, right? The second term, it is a product. So I said we do need to consider the product rule for the second term. So this is my calculation for the first order derivative. 3 cosine x, and then those 2 terms together, they are from the second term using the product rule. Let me double check if I'm getting this incorrectly. U prime, that's 2x, u prime v, plus u v prime negative sine x. I think I'm sure to be all right. Okay, we did use the product rule for the second term here to get a y prime. And then remember, this notation really means the second order derivative, right? d2y dx2. So I continued to calculate the second order derivative from here. This time, be very careful. The very first term is fine, but the cosine term going back to negative sine, okay? And then This second term I'm talking about here itself, it requires a product rule, right? So using the formula for the product rule, once here, 2x cosine x. Let me take a quick look here for everything makes sense. 2 cosine x, 2x, negative sine x. Everything looks fine to me. Okay. And then this part of the term, again, it requires the same product rule. Certainly, you are going to have different u's and v's. So u is 2x. I think it is fine. And then u x squared, v prime negative sine x derivative, that's negative cosine x. So the second order derivative turned out to be pretty long, I say. And then in the end, make sure you have the answer simplified. And let me double check. I think this negative 3 sine x stays. 2 times cosine x, it still stays. And actually, one thing I just realized, these two terms are exactly the same, right? This is minus 2x sine x minus. Okay, so I did combine them into single one, negative 4x sine x. The last term, that's negative x squared times cosine x. So mostly I should be fine. And at least for now, I think I should be fine. If you see anything wrong or anything not right, do let me know. And again, this is one of the homework problem, number 210. Number 210. If needed, do take a look if this is helpful or useful. And thank you for watching. I'll see you next time.